Login accepted.
And for the beginning, let's a moment of gratitude for you, because being on the podium here with this number of votes is amazing. Right now, it's over 330, I think. So we deserved a big room. But the more important is your interest in that. Okay, testing is simple because you have a simple choice to do. When you're writing a new test case, you have a simple thing to choose. Either you're choosing SRC test or SRC integration test. You have two directories. One is starting a Spring and another is not starting an app. So the only decision that you're about to make, whether you need Spring in this test or not. And probably even simpler would be if you could pick not by directory, but selecting the directory, but by just putting everything in SRC test. Somehow build tools forced us to create two separate directories, but there are ways in the 21st century to somehow overcome this. Okay, so the units and integration, well, it's easiest to define those bastards starting from end-to-end, because end-to-end is everything, right? End-to-end sees everything. Like the folks above, right? They see everything. And the integration floor lower sees a bit less, so they cannot test everything, and the units can test just a subset of features in isolation, and this is what we want to achieve. But sometimes the isolation that we are picking might not be the best fit. The important part is that unit has different definitions across the teams, that's certain, but also within the same team. We call a unit a single public method. We do not admit that we are testing private methods, right? So the public method and also the class might be a unit, but also a set of class called a module, component, or a fragment of the application. We also call it a unit. So we have a lot of definitions of unit, and if you are right now going to the definition of integration tests with the Vogue definition of unit, we are unable to define integration. We are able to define end-to-end because it's everything. So we're testing the whole scope. We are not isolating anything. Maybe external vendors, but who cares? And it works. It works for small systems or for microservices of certain scale, complexity, or pace of change. If I'm not changing the system, then the tests are, less important than in the case where I am changing. Okay, so I've picked a big system for this presentation, just to have. It's not that big, but it has users and external vendor, external APIs. So it's big enough to show the different approaches to testing when it comes to picking the right strategy to the right class of problem that I have. And I'll be doing some pauses. There are no comments, no questions, so just heading still. So with domain-driven design, we have certain building blocks. We have different approaches to implement the internals of our applications, and one of them is tactical patterns from domain-driven design. Let's do a short recap. First of all, we have domain, because, well, it's a domain-driven design. So we have a domain entities and domain services. They're responsible for domain logic, and which is obvious, but basically they are guarding the rules, the domain rules, the important domain business rules, like I cannot withdraw more money from my account than I have in my balance, or with a credit limit. I'm calculating the scoring, which is a part of domain services in most of the cases, pure functions. I'm giving you everything I know about the person, and please return me how much trustworthy this person is. Can I give him a credit or not? Above we have process. So this calculating, scoring, or checking data is just a part of the process, one step of the process, and the process is implemented in application services. There might be different steps like sending email and saving to database. So saving to database is a repositories layer, and web clients or external event publishers are responsible for interacting with the external world. And we need to somehow access this logic. To access this logic, we expose it, the API either by HTTP or by some event listeners or by command handlers, like from Java to Java, right? We're just calling Java methods. It doesn't always have to be public. Oh, that was an accidental click. Oh, fine. So I've named the first microservice here the units and integration service, because for well-designed and well-crafted, fully fledged domain-driven design patterns, I could apply the units and integration testing strategy. But as you see, it's maybe you see, maybe you not. I see because I know what's on the next slide. That there are some parts that are somehow not covered one to one. We have units per class, units with mocks, which have a special place in my heart, and unit per module, per method, and unit we call everything. The integration part is different from unit because we are calling API, the controller API, and we are checking if something is in a database. So we're checking the integration. That's the scope of integration, right? And end-to-end, which is testing everything. So my system integrating with the whole, my microservice integrating with the whole system, right? I'm just a part, small part of the bigger system. Yeah, so let's take a look at how we could approach it differently. I've named a second service in my big system a DDD service, which is crafted exactly the same way as the previous one. But let's focus on how we could test it. But one step back. Step back means what are we doing actually when we receive a request to process in our system? First of all, we're validating it. It's a syntax validation, like whether this field is a number, like age, is it a number? Or email, is it a string? Or do we have an array of preferences? This is a syntax validation, simple syntax validation, whether it fits. And the business validation part is that age, it's not enough to be a number, it has to be above 0 or above 18 if we require the user to be adult, or above 16 if this user is from Denmark, because they are somehow happier country because they have adults 2 years earlier. And then we have a process logic. So once we validated everything and we know that it's clear, we can start a process. Start a process, which means, for example, when I create a user, I'm storing it into the database. I'm ensuring that he's over 18. I'm calculating the scoring for him. And this part is a domain logic and domain and computation logic. So I'm calculating the scoring. If we took an example of creating a user with scoring, then I have to save it to database, which means that here I'm validating the data consistency. It's a repository who is doing it. Because the data consistency across all of the records, all records that are representing users in my database, the email has to be unique, right? So I'm not going to check it into application because we know the database will be more performant in doing it. So yeah, a part of logic of processing request is in repositories. It's a data consistency check. And I'm interacting with dependencies, whether the email was sent as a part of a process, as one step of a process. Yeah, and now we're gonna play a matching game. The requirement is that we have to be at least 1 year old, and the challenge is to fit those small blocks into the holes with the corresponding shape. So we're gonna be matching something to something, and if I would throw those two things on one slide, one next to each other, when we are processing request and we have a tactical DDD building blocks, can we match it? Yeah, 1 to 1. So each building block is responsible for a subset of things that we are doing on a request processing, which means that each building block has clear responsibility. Might be quite obvious, but I need it for the next slides, for the next things that I'm gonna introduce. Let's see the scope of tests. So when I get a request, what I need to test. We've seen what I need to, how I'm processing it, so probably I will be testing the processing of this request. First thing is that I'm validating on API whether API is correctly exposed. So I'm sending a REST request. I need to check HTTP method, security, params, JSON body, response body. This is API test, which is a syntax validation, basically. Because in JSON, I expect particular field with particular name to be a number. And this is syntax. I'm doing the validation tests, which is, it's not only to be a number, it has to be a number above 0, greater or equal to 0. So this is my validation test. Then I'm testing the process. So my process tests, and they have arrows, outgoing arrows, so they will be testing the interactions with another, with a different blocks. And one of the blocks is the domain tests, right? So I'm testing the domain. I'm testing my domain rules and my domain services, which are functions. Data consistency belongs, okay, I need to say, to the repository. So I'm testing it there. And the dependency, I'm testing with, wire mock or checking with whether the dependency was called with the proper params. And again, we're gonna be matching stuff, and you probably know what I'm gonna match, because yeah, I'm just drawing those two things, scope of tests and DDD building blocks, and yes, I'm matching them 1 to 1, which means that my API tests are basically focusing on my controllers, event listeners, or command handlers, which means that I know that when I'm calling the API of my microservice, the whole machine under the hood will trigger and it will be fired. So if I look on the coverage report, yes, the coverage will also be reported on the lower layers, but I do not care about it. And the focus of API tests is to test everything that is written in controllers, not on the lower layers, because on lower layers I might test with isolation. We'll start with that. I'll show you exceptions later. So that's not always, that always is not a good word in IT. It's always, there are also exceptions. Fine. So drawing the same, but in a different shape, we have layers of tests, which are API tests, and at the bottom, we have a validation test, process test. I've merged computation test and domain test because they are testing the domain. And I have a dependency test, so I'm testing the interactions with my dependencies. My database is just a subtype is yet another dependency, some specific one, but a dependency. Okay, and to add a bit more to this picture, we have a different verification strategies. Because, well, the first is the scope of the test. How big part of my application I will isolate for this given test that I'm writing, but also what I'm going to verify. I can verify the interaction. I drew here component and a database. Database is a dependency. So when I'm calling a post request and I'm verifying the interaction, I'm verifying this part, whether during the process that I've triggered with my request, whether the this interaction happened, like whether something was inserted into table. I can verify it. Whether external API was called with wire mock, for example. I can verify the output, so a pure black box thing. I'm not checking anything what is happening inside, so pure black box thing. I'm just checking whether I got a response, so pure contract verification. Like I'm sending a post with this JSON and checking the response, whether I got correct JSON. I'm not testing the interactions. Sometimes I have to test the interactions, and sometimes I have to verify the state that was set, because not everything is in a response. I'm testing the logic that is not presented on a response when I'm verifying the output, but it is important to store the state. So I'll be verifying the state. It's a kind of more gray box testing, because I know how the implementation works, that it is saving a state, and the state has this kind of format, like these columns or these fields in NoSQL. Where am I testing internal processing? Actually, nowhere. I'm not verifying the internal processing, how it works, because it would be completely white box testing. I don't want to know the details of internal processing. I'm verifying the results. What can I observe? And I can observe interactions, outputs, and state as a result of the request processing. Fine. Next part again. Let's see how does it match to the building blocks of domain-driven design. Interactions are here. Like application services are interacting with different parts of the application, so we can verify whether they interacted with it correctly. We can, if we are approaching it in a granular way. Also, repositories and web clients are interacting with either database or external HTTP APIs. And output base, which is nice, we have a lot of possibilities where we can verify only output, which is our basically holy grail. On controllers, yes, we are checking whether we mapped request properly, handled it, and mapped to the response, like JSON output, JSON input. Same for domain entities. Yes, they do have state, but we are changing this state in the application. So basically, we are saving it later to the repository, where we can verify whether this new state was persisted. And the domain services as a pure function, stateless, are a good case also for black box testing. And a state base, yeah, state we are setting, we are persisting state in database or with event stores or with in external systems. Probably most of the cases, the state is being set only in a database. Fine, and again, matching game. Seems that API tests are output-based, and same for validation tests, because we are sending the data and getting a response, whether this is correct or not. We are creating an object with a factory, which in response we expect a valid object or an error. And the process and end-to-end tests that are doing everything. Right? They are checking interactions, outputs, state. We have crazy testers, so they are checking everything. Once I even tried to match those tests, scope of the tests, with some kind of naming. And this is very old slide that I was using for that purpose. And seems that it's not needed. I don't need to map it. I was trying to map it to do recognizable things, like mapping here a business logic test. There is a dot that this is a unit test, and this brings a bit of confusion. Same component test I've matched to the business process. It's yet another layer of mapping which we don't need. So I stick to naming them like business logic test, process test, and computation test, not unit, component, integration, API, and so on. I have to show the pyramid because it's a presentation. You know, whatever I do, I have to land in a pyramid just to reflect to the current state of art or knowledge, because pyramid is everywhere. So I'm referencing the strategy here, the building blocks of a strategy, not the strategy yet, the building blocks of a strategy. The building blocks like domain test and validation tests are at the lower layer. They are fast to write, they are isolating the scope, they are small, which is similar definition to unit. Above, I have a process test and dependency test. And the process means that I'm integrating stuff below, like domain and validation. I'm right now setting it into a process. Dependency tests are checking the database and external interactions with external services. And API tests are representing things that was so-called a UI test, which makes sense because user interface. REST is a good example of user interface. Fine. But well, how does it map to the fact that the integration tests were the ones that were starting an application context, right? Booting this whole Spring Boot stuff. I want to abstract it from the pyramid. It doesn't map one-to-one. I'm not starting, I don't have to start the Spring app, Spring context, if I'm on an integration test level. I don't have to split into two directories like integration test and test. I can have a test base. Right now, the test with Spring Framework is just adding an annotation, Spring Boot test, right? So I can add it to my test or not. If I add it, the Spring will start. If not, I'll have a kind of in-memory setup, and I can test my process and my logic and my interactions with external dependencies without starting Spring Boot with unit test. So 1 second instead of more. I don't know how much your test might take. And what do I achieve here? Is that I have a single test directory, and I have the same package structure as I have in my production code base. The difference is the suffix. Like I'm saying that I'm testing the REST API. Yeah, and it's in a package of API REST. I'm testing the component. I'm testing the component with Spring. I have the all place on tests in one place because I'm focused on the scope of the test, not whether this is integration or unit. So I don't need to watch two directories and think where this guy put a test on this feature, unit or integration. Yeah, and I need to scroll both to find out that actually he put it nowhere. Fine. Let's back to the big system. And DDD might be service, because DDD is present, but mostly on slides. In real life, we have a different architecture. We might have the same complexity, and it might be implemented in a DDD fashion, but it is not. So we have services that are doing validation process and the domain logic, right? It's very often the case. So we need to map. And what I map is that we're merging things. If we are not able to isolate and distinguish the validation, the process, and the domain, we are just merging it and saying that, sorry, with this setup, we apply this strategy because we can have only a module test. I've named it a module, you can name it a component, whatever. But basically, this is those are the tests that you in your team are agreeing that they are checking validation, process, and the domain. I might have some single small test that is checking just validation, but it's rather an exception, than the rule. End-to-end, as always. And the pyramid, it is still the same problem. In the problem space, we are solving the same problem, but with different tactical design. Not especially the DDD one, but some accidental one, right? The layered architecture said that we have UI services and entities or something like that. Module tests are still the most important, and I'm trying to write them without the framework, if possible. Okay, let's head to something simpler. not every service, I mean just 10% or 5% of services are that complex. We're also having a capabilities, service with capabilities, simple ones, like create, read, update, delete type, right? So it's just a wrapper for a database with some additional features. And basically, how it might look like is, well, again, related to DDD, but there is no process. There is no application services because there is no process. There are no domain entities because there is no domain. There is just controllers and repository. There's no logic. It's a kind of system that you're able to explain in just one sentence, right? Hey, I've added this user to the database and I've queried for it and it was there. Why? Well, because you added it, right? There's nothing happening except that. That's simple. We're checking whether the email was correct, whether it's unique, and so on. But there's no complex process. There's no deep logic in there. And fine, does it match? Yeah, if I cross out those two things and focus on API test, it matches, right? So I'm just skipping a part of scope of the tests, and I'm having it. So we have yet another class of system that is where I apply a different strategy than the previous one. Probably that the strategy will be a bit similar to inverted pyramid, right? Upside down. So the API test, I do have sometimes, I don't even have a services layer at all. I'm calling repositories straight from the controllers. Why not? If I don't have logic, then I don't have services. I do have validations, value objects, and factories. I need to check it, but I don't have a process for that. So API tests sometimes are sufficient. And process manager, something complex, something more complex. Because there is this guy above that is managing the whole process. It's not a process within one service. It's a process, it's a business process that the user is in. So what this guy is doing is basically focusing on application services because they are implementing the process. So I have process tests that are most important in my tests. So the strategy, I called it a process manager. It's for services of kind, like integrations, sagas, process managers. This is where I would apply it. Right? So I skipped the validation because validation is on lower levels. I mean, I can do some, but it's not the core feature that I want to test here. I don't have a domain because the domain is below, right? The services below are implementing the domain. Fine, and we end up with a diamond. So the process test is the biggest, the most important part of testing in this setup. And the web frontend. Yes, I'm gonna say several things about the web frontend. And it's similar, isn't it? Instead of API, I have HTML, which is calling the services because they are calling the backend. So the strategy here is, again, a process manager. So I'm applying the same approach to the different, completely different class, completely different technology, but the class of a problem taken from the perspective of testing is actually very similar. Let's go to the hexagon, and yeah, it's yet another representation of tactical design patterns from DDD. We draw it differently, we achieve a different results with it, which is fantastic, but from the perspective of testing, we still have domain inside, we have APIs and external dependencies and end-to-end test, but maybe we can draw it a bit differently. So in left top corner, it is the strategy is named DDD. Why not? So we're observing now that the things are repetitive. So we might have a classes of problems that we are solving with our software, and we can match classes of strategies for testing it. With ACL service, which is anti-corruption layer to external service, yeah, the similar thing is that we don't have a process, we don't have a domain, we are just having similar thing like we did in the CRUD system, right? Instead of repositories, we have web clients, which is again, we are testing with the API tests mostly. We do not try to find an application services and over-engineer this stuff, whether it comes to the production code or tests. And the black box service. I've named it a black box service, which is that which can you might be thinking that this is something perfect because we need to encapsulate, we need to black box things and test it in a black box manner, but basically it's very often a legacy where I know how the system behaves because somebody is calling it and getting a response and it's making money, but I don't know what's happening inside and I'm afraid to touch it. With this guy, we probably have, we have logic in a controller, but the problem is we did have it in a simple service, but the problem here is now that there is a process, there is a domain, but somehow tangled. So we are not able to test like we would. The only thing that we are able to test sometimes is the API behavior on the API, and this is our safety net. Then maybe we could dive one by one and write some more tests, but basically the pyramid gets inverted. We don't know, we know that it shouldn't be, because there should be a regular pyramid, more on the fast test, but as for now, we are not able to write it. So the work on that will be to invert it and to focus on finding the building blocks, finding the more granular things, and to invert this pyramid to the proper shape. But the black box is not only evil thing. Same strategy I would apply for the new projects. Like in startups, we want to change fast. And whatever test strategy and whatever test structure or code structure we will use, we're going to somehow stiffen the test and the implementation. And we don't want to have it in a fast pace, quickly changing systems. Because, well, I want to react to the market fast. I'm in a genesis, or I'm just thinking that I'm inventing something new. I don't know what will be the scope of this service. So the only thing that I know is the behavior that I can observe. So, I'm able to test the behavior. I intentionally don't write lower layers because, well, they might change depending on what will end up. Those of you who are in startup know that sometimes the things are changing very, very often and in unexpected ways. Good. One important thing when it comes to, I've skipped it, but it's end-to-end testing. This thing that we are scared and we're deploying to the environment and throwing stuff to the testers to come back to us with the bugs. There's this creature. If anyone spots the difference within 10 seconds, then raise a hand. There's this creature, it's Bebok. On Silesia, they were scaring little children with it, that it will come and hurt you or scare you. No hands up, because there is no difference. Yeah. And anyone hand up right now? No, we're using end-to-end test, I think, for scaring people, and this is their main purpose. You have to finish the feature because end-to-end tests are pending. Or this guy from end-to-end test came to you and is searching for you, is looking for you, right? So basically, there's no difference. And do we really have to deploy to the environment to check whether my systems can communicate? because end-to-end testing, the scope of end-to-end testing is pretty big. But if we take a part of it, the smallest part of it, like two services interacting, we have API consumer and API provider, and they are all interacting via HTTP. So they have a contract. What is a contract? They agreed, explicitly or implicitly, that when consumer will send this request, like post users with a JSON body, he will receive a response, like 200 with user ID, and this is the contract. I give you this, I want to get that in return. And end-to-end tests are testing both the contracts and the internal stuff within the service, inside the services. Sometimes they are checking ridiculous things like whether the username is not too long, not too short. It's definitely too high level to test such things. But if we would subtract and offload the end-to-end testing from contract verification, we could check and expect more test failures or more certainty before deploying to environment. So the scope of contract testing would be as such. Right? So I'm checking the contracts between on arrows is a contract. I'm checking the contract between, and I'm checking the edges, input ports, output ports, adapters between the services. I'm not looking into the internals of the services. It's already tested with API tests. It's already verified. So I'm just testing whether they can communicate. Contract means only JSON that I send you. I expect a JSON as a result. So involving a logic in contract testing is risky because, you know, there is a, I've tried it. That's why I know that it's risky. It just doesn't pay off. Okay, so I want to test it on my local machine, and I can do it with contract testing tools like Pact or Spring Cloud Contract. I can do it on my local machine. If I can do it on my local machine, then I can surely do it on a CI, which is a perfect thing to verify that, to somehow emulate a monolith, which is, you know, in monoliths when I was in Java code, let's say in a single deployment unit, when I was calling a method and I forgot to add one parameter in the contract, in the interface, then I got a compilation error. So this is what I don't have when I'm exposing or calling the REST API. And contract testing is a way to emulate it. Right? So if you're calling a REST API that the API provider is not providing in a way you expect, then I want to get an error. And I want to have it verified. So this is a screenshot from Pactflow. The Pact is one of the tooling to emulate, to implement contract testing. And you see that I have successful verifications. I have my consumer and my provider that are matching. So I know that the contract is correct. I'll leave the questions just after this slide, okay? It will be the next step. So the important part is that I know that during my development or continuous integration build, I can check whether they have a chance to work on environment, right? There still might be a bugs when it comes to the whole end-to-end process, but at least they are able to communicate in a way that they expect. Fine, and having that verified, I can verify, I can report on which environment I'm in, which means that if provider has deployed to test QA or prod, then and only then the consumer can deploy to those apps. I can ask the tool, the broker, Pactflow, or any other kind of broker, can I deploy to prod? And it will check what kind of contracts you're expecting from which providers and whether they are deployed on prod. So my deployments are more secure. I don't have to use Slack to ask this question to other teams. And actually they don't know because they are deploying with the pipelines, they passing it over to testers, so their answer is not always the truth. The truth is here, which is automated on continuous integration. Can you show Bebok? That was a Bebok. The funny part is that in a description, the first sentence is that nobody has ever seen them, which is a difference between end-to-end tests and Bebok. Somebody has seen it, and the pain was very, very big. And another thing, yes, I'll share the slides on LinkedIn maybe. I'll put a link on my LinkedIn, so feel free to invite me. Do you recommend any literature about strategies for untangling the black box layers? Untangling the black box layers, yes. It's dealing with legacy code. I don't remember the authors, but there are strategies. There is a lot of automations described in there, and what you have in IntelliJ, like extract method, move to another class, those are patterns that IntelliJ took from this book to untangle it. But when it comes to refactoring code, maybe it is simpler, maybe it is not. The problem with black box layers is that there is no clear separation on how to refactor the code because we don't know the business sometimes, and that's the problem. So for that, it's a knowledge crunching sessions, which might be even storming, any kind of workshop, brainstorming to finding the people. So it's more like a process problem, not a technical problem, I think. Yeah, so that is refactoring the legacy code is the literature. Let me find the more actors pre-count contract. That's a good question. Probably you have some experience already. I recommend Pact. I've tried both. I've introduced both in a production project, and for sure the Pact is the thing that I recommend. Both are not perfect, especially when it comes to documentation. The documentation is hell. I've started with Spring Cloud contract, and I thought that the documentation is poor. But maybe it was because it was my first contact with the contract testing. And that's what I thought. And it turns out that for Pact, the story is the same. Right? So the documentation is also difficult, but Pact has a nice tooling, like the Pact flow in here. It's a very nice tooling. It's a source of a repository of contracts and verification results. And I can ask a simple question: can I deploy to the environment? Of course, my provider has to, or consumer has to report that I have deployed myself to the production. And then consumers can ask, can I deploy to production? And this question makes sense. But the tooling gives you support for that. You have different versions of contracts. In Spring Cloud contract, as opposite, you don't have a central broker. You're just storing a contract in a simple storage. The implementation of storage in Cloud Contract is the Maven repo. So they are building a jar and publishing it to a Maven repository. So yeah, the tooling is much, much better. The best strategy to convince leadership to let us include testing code. There is a pressure, yeah. And the pressure is that I think that we deserved it, because if we are talking that building this feature will take me 2 days, and with tests 4 days. Yeah, no comment, right? Building this feature will take me 4 days. That's it. So I wouldn't be convincing anyone. I'm just saying that this is my work. This is how I work. This is my craftsmanship. I'm just writing a test. If you want it really fast, yes, we can negotiate. I can simplify the implementation, do the POC, test it differently. I can adapt. It's not always that 4 days are a must. I can speed it up, but it's informing about the technical depths. And testing asynchronous patterns like event streaming. The strategy is, I didn't have a place for it in this slide. The strategy is to make them in tests, make it synchronous. Every asynchronous interaction to make synchronous. If I have event publisher and event listener, I'm connecting one with the synchronous publishing and synchronous listening in Java in my in-memory implementation like synchronous, not including an external broker that is introducing asynchronicity. And same for threads. If I have a thread pool in my production code, I'm just using a one thread in a test. So if I have a scheduler in my production code, I'm calling this method directly, the scheduler method directly in my tests, not to wait. Of course, I will have additional bunch of tests to check whether my assumptions and whether my asynchronous code works, so a kind of more integration tests. But just a few of them, because I'm adding at scheduled, right? So this is what I have to test, but in my unit test, I do not use it. I will test the scheduler in one test, slow, that will wait until the scheduler will hit. So the event streaming, I'm just calling Java method. So I'm not always, I will have a one test that is publishing an event to the test container and to check whether this is consumed by my event listener at event listener. But to test the logic behind, I'm just calling Java methods in my unit tests. Okay, one more. I don't want to introduce any delay because there's a dinner. What infra and setup is needed for contract testing? Basically, if you don't, Spring Cloud contract is free. You just publish to Maven repo. Maybe you have some internal one. But free is a poor man's contract testing. You can set up a broker. There is always a central thing needed to store, to persist the contracts. And in fact, this is a broker. It's open source thing, so you don't have to buy it. You can host it on your own if you have friends within the DevOps teams. So just that, like that broker or the Maven repo. I'll be having a separate presentation next season probably about the contract testing. I mean, introducing the contract testing, implementing, not just the theory, but how to implement it. Miracle or disaster? Why disaster? I think they are solving a bunch of problems. They might be, again, overused, like mocks. Is it a miracle or a disaster? Well, it's a tool to use, and you need to know where not to use, where to use. The fact that you can boot a test container like Kafka or database in tests, it doesn't mean that you have to boot it in every test. Still, it's just replacing the poor parts that weren't possible without the test containers. So miracle or disaster. It's 1 or 0, right? I'm not this kind of guy. I always see where can I use this tool when it's reasonable and where not. Okay, fine. That's all questions. Thank you all, and let's head to the dinner.